Oh, that sounded like a very American lady telling me that recording is in progress. Okay, 1 more minute. Sorry, I see that the breakout rooms are still filling up, so we'll give it another minute or so. Good morning, Henny. I see you also in this room. They're from UJ. Good to see you. Compliments for the year.
Thank you, Wessel. Yeah, I'm in self-isolation at the moment, so a bit of a shaky start to the new year, but I am in the back, and thank you for hosting this, Wessel.
Oh, my
I know
word.
I dropped a hot potato in your lap last year this time.
Perfect. No, it's good. And thank you for the collaboration on this as well. Please look after yourself. It's unfortunately trying times, but please look after yourself.
Thanks, man.
Yeah, I see there's still a few participants joining. Last year, the year prior to that, before COVID, we had a session at the Mandela Mining Precinct, and I did a presentation, and I encouraged everyone to come and join our room. And then, then out of like the 60 participants, I think 59 of them came to our room. We had to send them away. And hopefully today we've got many participants in this. I'm very excited about the technology that we illustrating here. And again, I've made specific reference to Henny because quite a lot of the technology was set up into their mock-up area at UJ. So very exciting things happening. But I will take us through the presentation. I'm going to give, if you don't mind, I see it's 10:29. I'll give until 10:30, and then we will we'll start with the session. Okay, good morning. So I did introduce myself a bit earlier, but my name is Wessel Buerta. I'm from Enterprises University of Pretoria, and I was the project lead for Work Package 3, which was the aim was to find a modern training methodology for the upskilling of miners. I'm going to share a presentation this morning. I'm just going to switch off my video due to using or trying to, for the videos not to buffer as well, and trying to minimize our usage here in terms of our landlines. So good. Welcome to everyone here. A big focus for us in this session is engagement. It is participation. It is getting feedback, inputs. It's also for us to show what we've done, some of the outcomes of the study, and to finalize a lot of the findings. And at this stage, I'm going to present the presentation now. Gillian Michalowski is also in the session. She's also from the University of Pretoria here. Gillian, if there is specific, if you can just look at the chat, if there's specific questions coming up, or reaction for raising your hand. If there's a question, please just unmute yourself and pop in and just say, Vessel, we've got a specific question. I'm going to share my screen now and just make sure that you can actually see. Let me go there. Okay, we should have, you should be able to see my screen at this stage. Okay, there we go. So, morning, ladies and gentlemen. So, part of the SATCAP projects, the successful application of technology centered around people, we had the privilege of researching VR solutions for the upskilling of miners. Now, the aim of the project is to source a modern training methodology or solution that will enable the upskilling of miners to support mine modernization, obviously within a healthy and a safe production environment as well. So we needed to go and actually go into market. We have then engaged with OEMs. We will show now some of our partners that we work with. A large focus was on gold and platinum group metals in the conventional mines, and to see also how this can be applied to a modernized setting. So again, like I did in our introduction in the overall panel discussion, was to say that there is it's a transition. You can't have a simple switch off and a switch on into a modern or modernized methodology. And the approach of blended learning came through quite drastically. So we also needed to make recommendations as to what industry could possibly uptake. Now, there's a lot of that technology that's expensive. There's some that's a bit cheaper. There's various solutions that we looked at. Now, the team that was involved into the solution development was us as Enterprises University of Pretoria, which was part of the project management team. Win-win in collaboration with UJ was actually there to exhibit the design, and they were also part of our project management partners. We then also engaged with Sibanye-Stillwater that provided us the current modules of what the training is based on. And we focused our research specifically towards the RDOs and the DROs, the rock drill operators and the drill rig operators, and as part of the mining team. So it's just so that we could focus the study and not keep it too broad. And I think there's some excellent VR solutions that came out specific to those two positions. That brings us to STS 3D, which is also in this session, as far as I'm aware. One of their expertise, they were our solution developer and the supplier. We also engaged with Novatech and HPE into what the current methodologies are. So the focus was, what are these people currently doing? How are we doing training on site? And how can we possibly contribute to the betterment or the modernizing of this training? So currently, I know it's easy for us to jump into how the training is done and what we should do and so forth. I thought it best for us to first just understand the levels that we are operating at. Now, this comes from SACWA and is a quick illustration as to the various NQF levels. Now, most people in this panel they're familiar with what the NQF levels mean, but it's necessary for us to understand that we are operating at the level 1 to 3, round about here, in terms of our educational levels. Now, this is grade 10, where we are looking at. This is matric, grade 12, that we're looking at. And if we are speaking towards things like digital literacy, if we are speaking of overall of literacy, I think it's necessary for us to understand that we are predominantly between a level 2 and a 4. Part of our requirements as a rock drill operator would have to be level 1 health and safety practices as a learning assumed to be in place prior to us engaging further at a level 2. Now, the example of rock drill operator can either be, we can either complete the unit standard, or we can actually do an occupational certificate. Both of them are still focused towards an NQF level 2. And is often the site has specific requirements as to what the rock drill operator should undergo and what type of training should be be provided to that rock drill operator. Again, Gillian, if there are any specific questions coming through, I request that people engage with us and raise their questions as we continue through the presentation. So the example that we utilized, we looked at the rock drill operators. We also looked at drill rig operators. So basic module title is to drill holes by the means of a handheld rock drill. Now there is obviously specific to water, to compressor, air, or to water. And some of those unit standards have also not even been updated. And that's been a concern for us in terms of the regulators of education and training in South Africa. Those are basics that need to be addressed prior to us even looking towards the inclusion of technology and, you know, taking it to the next step, if I call it that. So what did we do? We actually used a current unit standard where we can look towards how it's being done now and how we can contribute further to the upskilling of it. So the unit standard will be useful to help people who have to drill holes by means of a handheld rock drill, a specific focus on the marking of the rock face. Now there's a quick illustration there where we actually were on site by Anglo, and we engaged with them into the VR wall that's been set up there, so we could go and see practically how it's done. Now, as I said, specific focus was on the marking of the rock face and the example provided there. So there's the module that we utilized for 24415, and the actual outcomes of the learning objectives would be to explain the specified requirements pertaining to the drilling of holes, prepare for drilling, the drilling of holes, and then perform post-drilling activities. Now, specific to the face marking is that we can't do the actual drilling of holes, but it provides you an example of correct or incorrect face marking at this. So this just basically provides us for that preparing for drilling, and as well as explaining the specific requirements that needs to be done prior to the drilling of holes and the marking. So again, this is where there is an instructor right next to the learner. The facilitator can then show a best practice, like you can see on this slide, on this photo here, where they can show this is the best practice and what is the actual requirements, and the learner can then undertake the exercise themselves and practically go and try this again within a safe environment in an area that is controlled by the facilitators and the work site. So part of it is the purpose and what it would be aligned to. So it is to promote general skills, knowledge, and the understanding of persons responsible for drilling holes. And this is what the VR solution can do. It does the increase in terms of the skill levels of that miner, and also then focuses on the competence levels. Where miners can actually be informed as to the consequences of wrong marking, of incorrect procedure following. Now, if we look at some stage, we did the VR stope as well. There is, and we'll see it in some of the videos that we're going to show you now. There you can actually practically see what the consequences are of marking incorrectly and drilling incorrectly. So it obviously needs a big focus for us was to focus on the knowledge, the competence levels, and the practical skills of effective drilling practices. So the module illustrates the causes of following incorrect procedures, like I said, and wrong face marking as well. So the purpose, the training is there for upskilling. That's the big purpose. Part of the findings from the study is that we cannot simply replace the current methodologies. There is things like on the job coaching that still contributes tremendously to the effective drilling of holes. But what we also want to encourage is things like self-learning at the end of the day. Now, we spoke of things like gamification in our introduction, where we can actually have learners that compete against each other in a positive manner, in a friendly, competitive manner, if I can call it that. And this makes sure that learning is taken up in a formal as well as in an informal manner. Now, Johan that's on the session as well, he can testify that one of the facilitators at one of the sites, he would have learners come back, after shifts or when they're off, to come and compete and to see if they can increase their accuracy and you know, pattern marking and so forth. And that just shows how something like new technology can be used and to the betterment of skills at the end of the day. Now, as I said, we utilize then the basics of a unit standard or an occupational qualification. We also then further developed Win-Win in conjunction with Sibanye, also then further developed a exemplar module, which will be available on the RTIM system at some stage, where we took the current unit standard, current material, modernized it a bit, made it more accessible, and then linked it back to the actual VR technology in place. Now, we know that unit standards and these qualifications into the CETA frameworks, they are credit bearing. What we have recommended is that we look towards an additional 2 credits for using simulations. The CETAs, this is still obviously CETA approval dependent. And what we mean by those credits is the amount of time spent on learning practical skills. Now, quite often what needs to happen is there's a percentage split in terms of theoretical versus practical learning that needs to take place. And part of our recommendation is to say, let us utilize simulations and this VR environment as something that can contribute further to your qualification at the end of the day. And I think that's something that would be a big considering factor for the CETAs and the QCTO at the end of the day. The duration, again, this training can take half a day, full day, depends on what type of VR experience we are looking at. If we are looking towards something like the VR wall, the blast wall, it's a large setup, it's a big environment, it's a dedicated space that is required. If we're looking at the drill rig, it is more of a mobile unit that can be set up on a desk somewhere in the training facility. And again, we brought it all back, both of those technologies back, to say that it can be aligned back to NQF level 2. But that what is the further contributor that it can do, instead of just upskilling someone into my current qualification of NQF level 2, we can actually utilize this to upskill miners into a potential NQF level 3. And that takes us back to the actual individuals progressing through these levels. And that's, I think, what technology can be utilized for. It's been an aim of the educational institutions and the regulators to have people make a progression, that horizontal progression into the NQF levels. Now, technology can genuinely assist with this process to add to the progression of learners through the NQF levels. So what else are still some of the foundations? If we look at our assumptions, for you to start utilizing this NQF level 2 unit standard, we need to follow basic occupational health and safety practices at NQF level 1. So we have not, again, here you can see, we've not just chucked out the current handbooks and textbooks. You still need to understand what safe making practices are, following safety procedures, etc. Prior to you engaging with this, because we can have pre-assessment training and post-assessment on most of this VR solutions. We can then say, what are the pre-assessments that we need to look at? And what are the basic safety procedures and practices that the site wants to have implemented prior to entering a work site? And that can already be part of the VR solution at the end of the day. So at the end of the module, the learner should be refreshed on, or should be competent towards explaining the requirements pertaining to the drilling of holes, conduct the actual effective marking and drilling and blasting operations in a safe and proper manner. The explanation of the significant risks and consequences. Now, I think that's things like hazard identification or risk assessment that still forms part of the foundation. And then the explanation of the consequences of safety, occupational health, and production if specified requirements are not adhered to. And I think this is a big portion of the findings from the study, is that the consequences can now actually be illustrated. And you'll see that at some stage on some of our solutions. Apologies, just want to close my door. Is that in the VR environment, a learner can now actually go and experience the environment. So let me say learner. Let me rather use a supervisor. I come in as an external supervisor from a different type of operation, let's say manufacturing operation. I come into a mining operation. I can now, in a safe and a controlled environment, actually go into a stope and go and see what it looks like, what it feels like in terms of the height. You know, everyone says, oh, you know, a rock drill operator, you know, 1.52 meters, that's not, you know, that's not it's not a lot of space, but you can actually now go and feel what it what toll it takes on your knees. You can actually go and look at what it would look like. The environment can be developed, set up so that you can have a real look and feel towards the environment at the end of the day. And now if I am marking incorrectly, the VR solution actually then shows you what the blasting pattern would be then. If we're also looking at placing, you know, the placing of explosives and the incorrect sequencing of that, it now shows you what the best practice would be and what it would look like versus what you have done as a learner. So I think that is a big takeaway for us from this study as well. So learning methods, it's a virtual reality interaction. The training is very practical in nature. It's very interactive. Learners engage obviously directly with the equipment in a virtual environment. And this should be combined with the current traditional classroom-based and the instructor-led training at the end of the day. The assessment criteria does not really differ that much from the current methodologies. The only thing is that it's a bit more accurate, it's a bit more real time. It actually, the instructor can measure it immediately on site there. It's not a textbook with a textbook response. It's a practical illustration, it's a practical engagement. Things like inspecting the equipment, ensuring the tools are in working condition. In the VR stope, there's specific pre-assessment prior to even entering the stope. Which tools would you utilize? What inspections would you do? What health and safety checks and balances do you actually do prior to entering a work site? And that's what preparation of work area, the accuracy of marking, following instructions as well as giving instructions. The facilitator can actually sit there and say, listen, this is the pattern. This is what we need to do. Or the learner can say to whoever's marking, how do I actually provide instructions to the effective marking? And then accuracy of blast sequencing, which is also part of it. Because it is interactive, it shows you how to mark, and I'll show you on the next slide as well, where we've got a photo of that, and what is required from that commodity or that site specifically. And then I think it was Nancy that also spoke about CCFOs. Now, this is the critical cross-field outcomes. What we found as well is that even though we might have someone that does marking correctly, we still have the other softer side of the skills development that needs to take place as well. And part of that is things like organizing and managing yourself, your activities, your team's activities, you know, working effectively with others. Is that team dynamics? Is that communication? Demonstrate an understanding of the world as a set of related systems. And that is things like, as an example, that's already been taken up into market, into the sector, is systems thinking, understanding that my actions have consequences. Again, VR shows this to us, but in a safe way. We can do multiple blasts on a VR wall, and everyone can see consequences without experiencing that trauma as well. You know, so. It also, one of the other ones is to collect, analyze, organize, and critically evaluate information. And I mean, if we are looking towards the future and things like digital literacy, we need to understand the data that we are working with. We need to understand the consequences of providing wrong reporting. We need to see what the data contributes to my job at the end of the day. And at the end, miners want to see what that means to their pocket as well. And that is what we mean by evaluating information, understanding the consequences of information. So a potential module for on-site training, I must say we went for a few site visits. It's very exciting. We went to Marina Roberts Training Academy. We went to the Anglo Training Academies. We obviously at UP, we also have a training facility there. And it's very exciting of what is happening in the world of virtual reality. And the virtual reality system of blasting is again, instructor assisted. So that's not only self-learning. The level of self-learning is not yet there in the technology that we looked at. Again, it's a future thing. I think the potential for future development into it is phenomenal as it becomes more mobile as well. And here we can see where in a STOPE environment, a 3D environment, and this is the first person camera view. This is actually what yourself, if you put on the helmet there, and it is literally like a hard hat that you put on, if you go in, this is what you see as you are sitting there. So you can see what the blasting patterns are, where support structures should be. There's your STOPE area, and what is best practice, and what should be sequencing of blasts to be done here. Now you can then go and take a spray canister and you can go and mark off. This is then removed as an example and say to see if you can do the best practices. So the facilitator can literally see what you are seeing from a first person view camera as well. So clear instructions are also provided through systems over and above just the facilitator being there. There's a voiceover of instructions being provided, and that shows or can indicate how well people follow instructions. The system still requires specialist setup and support, instruction for implementation, on-site support required from the OEM. The OEM still needs to be there. That's part of what the requirements are. So OEM doesn't have to be on site the whole time, but the setup is something that is done by specialists and by experts. So it is important to know that blended learning is still the approach recommended from the study, and there is the need for power supplies and sufficient dedicated area for the setup and so forth. So as I said in my introduction, I think it's necessary for us to look towards incorporating that as part of my training strategy. Now, one or two of the companies that we engaged with, they have incorporated it as part of their training strategy and already seen the benefit. Because if we are doing marking more correctly, if we are doing drilling more correctly, we are advancing more effectively. That advance and that clear blasts provides back to our bottom line at the end of the day. And I think that is still necessary for the miner to see and to experience. So traditional methods were converted into a VR solution, and that is, if we are looking towards here, there's still the Dover assessments. Myself, I've done just, I think, 3,500 of these assessments on mines. And those are Dover assessments that's still there. Still a very effective psychometric type of tool to utilize. But if we take this type of assessment versus what we have here in terms of an assessment report, and this was just a quick example that we did on the day, looking at what depth you've actually reached, and this is for the drill rig. What accuracy did you do? What the degree of alignment there was? And here you can clearly illustrate to the learner what has happened. So the learner can see behind the rock face at the end of the day. So what happens if I do it incorrectly? And I think that's part of what we can now say, getting back towards best practice. Again, these patterns can be aligned specific to the commodity. And the aim was to see how a transition could be made from the traditional classroom-based training to a modernized blended methodology. Now, we are going to watch a quick video. We've got about 3 videos that we're going to go through. This is the first of the 3 videos. Jillian, any questions currently from our participants there?
Nothing yet, Vessel.
Perfect. Okay, so I'm going to play the video here. Just give me a set up. There we go. Apologies. Oops. Sorry. And just let me know if the
building a one-to-one scale blast wall that people can interact with. Now, normally when you learn about mine theory, you've got everything on a page or a website or a PDF presentation, and yeah, there's a nice sketch on scale and distances and measurements, but you never get the real sense of feel as to what it feels like marking off a blast wall. It's like learning in a textbook how to do open heart surgery. Doing it the first time, you almost want to die. Am I doing the right thing here? So what we're actually giving the minds and the students is the ability to get that muscle memory. What does it feel like to mark off? I mean, it's easy to see in a book you're 2.5 meters high. You don't realize 2.5 meters is up here. So there's a scale blast wall. It's 3 meters wide, 2 meters high, and it's rear projected. So we use a projector to cast onto the canvas, and the users use an electronic spray can to actually mark off and measure. Now, in the olden days, they used to do blackboard and chalkboards and stuff, but as you know, doing the same pattern all the time, it gets engraved, so the student gets like, oh, I just mark off a little pattern. That's not the case here. So in the training mode, we also show the people step by step how to get to the actual marking pattern. Once they've marked it off, they put their blast holes, and the assessment mode will then show them accuracy. Green indicators on where they're accurate, and red indicators where they're too far off. We find that the students have a good laugh at this. You laugh at your classmates, you say, okay, well, you try better. And then there's a little bit of internal competition, which instigates training from the student side as well. Where it all started was Sasol approached us for the Mopani in Zambia, and I said, they're building a new Mopani, it's state of the art, it's world class, and they need something different. He said, well, let's do something electronic. And 5 meters by 5 meters high, wide, and that was the world's first ever electronic blast wall, where you can actually go, mark off, undo, redo, and see your blasting patterns afterwards. We decided to build in a little bit of gamification in there. You've got a top score. So top score calculates how accurate you are divided by the time that you take, and that will calculate you like Pac-Man a top score. Because you can see what you're doing, you can realize your mistake immediately. You're not doing something on paper, handing it in, waiting, getting feedback from the lecturer. You can see immediately what we're doing. You can see immediately what your mistakes are. In the training mode, they tell you measure 2.5 meters to the left, paint your mark, and then once you painted your mark, the computer will put in the correct measurements for you. So you can immediately see where you're off and where you're not on. You have the ability to undo, to fix yourself, to remedy your mistake. Well, when you get underground now, all of a sudden you know what the scale is about. So you built this muscle memory. You don't have to practice to get it right. You remember how far you had to measure, how high you had to measure. So the muscle memory really kicks back in. That means you can mark off quicker. You can mark off more accurate. As soon as you start marking off more accurate, you don't have overburden, underburden. You don't have rocks that break up too large. You don't have misfires due to incorrect timing sequences. So if you get your marking pattern right, that has a spin off all the way down to the concentrator. So your drilling is correct, your blasting is correct. Grizzlies doesn't get blocked up with too large holes. The crushers don't have to struggle with too much waste and contaminated reef. 10 centimeters advance increase here makes billions and billions of profits at the end of the year. You're not sitting in a real underground environment with real hazards where you're trying to just stay alive and look at all the hazards around you. You can completely focus on what the lecturer is trying to give you in a simulated mine environment that's completely safe. So instructors got your full attention. So that once you get to the real environment, you can focus on the real hazards while you've got the training already done for the blast wall. Well, one of the benefits is that a lecturer could, for example, come and say, right guys, what we've got here is a blast wall, but we've got a geological feature running through it. So your homework is go and figure out a new blasting pattern for what we're going to do. So come Monday, all the students go, and one by one they can put that pattern down. And once they're done, the lecturer can pull out the correct answer. And they can say, well, Bob, you got closest to what we've got, so we'll save your pattern and, you get the bragging rights for the day. Also, students get the ability in a free mode to go play around and experiment with new blasting patterns, see how it reacts. They can show it to the lecturer if they feel, hey, this is something new. They can save it, give it to the Mine Health and Safety Council, and they can say, well, wow, Steve has just got a new blasting pattern that turned the whole everything upside down. Let's save that, make it Steve's marking pattern going forward. Coming from the classroom above, which was nice and open and square, we obviously got a bit more difficult environment here. So first we need to clear the footwall, the gravel, to see if we can get the frame to fit. So if the frame's not high enough, we can't hang the canvas. So we're doing that at the moment. We've got some piping that we need to go over here to underneath. Then we're going to cut the frame to size, put on the canvas, and once that's done, we can start putting the projector. Then we align the projector with the canvas, making sure that we cover the whole area. We'll then start up the computer and we'll recalibrate the whole projection matrix, because obviously you can't align the projector perfectly. So use a bit of software to distort and warp the projection. That'll get us perfectly to the millimeter on size. After that's done, we will start installing the tracking units. We use Vive tracker units. That tracks your electronic brush. That allows you to paint on the face, tracking where you are, and we've also got a hard hat with a track on it. So after the blast, what we do, we simulate Ultra 3D, which gives you a perspective as you move around. You can see the depth and the overburden or whatever you left behind, and it really gives you a sense of depth without using goggles or 3D glasses.
Okay, exciting things happening there. So can everyone still hear me there?
Yes, we can hear you.
Perfect. So yes, guys, if I can just ask that if you can just put yourselves on mute, unless we've got questions. We, again, as I said, we'll open up at any time. Please just raise your hand if you've got a question. So that was the VR blast wall. Johan Bauer there from STS 3D. We've actually set up a full blast wall at UJ. I am very sad that we can't be there in person. It would have been, you would have seen the potential of the technology there. It's genuinely something phenomenal. Again, it's something that needs to be looked at a strategic level. I think the contribution, like Johan has said there, if implemented correctly, can be something that really contributes to the bottom line at the end of the day, to a mine operation. So that was one of the VR blast wall. If we are looking towards our VR drill rig, and this is with the... Cool. Can I just ask that we, Johan, that I've put you on mute there. Thank you. Okay, sorry, you guys, let me just share screen again. Okay. Gillian, there we go. Can you see?
Yes, we can see.
Perfect. Thank you very much. So the traditional methods were converted into a VR solution again. The VR drill rig provides real case scenarios for the learners within a safe environment. We based the technology on the Sandvik DD321 drill rig. The aim was to see how the transition again can be made from the traditional classroom-based instructor-led training to a modernized blended methodology. Now, one of the images here, which you'll see, is one of the drill rigs where we can actually look towards doing fault finding. It's excellent technology of an interactive touch screen that can also, you can rotate in real time around the drill rig, and you can use this as still the instructor in a classroom to illustrate where specific areas are on the drill rig. Again, it prepares certain learners for the environment prior to even entering the environment at the end of the day. And I think there is great potential for this going forward. Again, the example is was shown here for a drill rig, where the drill rig is in the back end, but we are looking from the rock face behind the rock. And I think this is something that VR can just illustrate to learners. So I'm drilling at this point, and here I can see, oh, my drill rig angle was not, or my drill bit angle was incorrect, and that's why I'm getting the wrong measurements at the end of the day, the wrong blasting taking place and creating pockets and so forth. So in this one, there's an actual the individual's hand. So you will put on the VR headset. Again, it's phenomenal, the type of technology, very interactive. I'm very sad that we can't be on site. There you can actually see your hands, you can actually operate the machine. There are physical levers in front of you where you can actually then manipulate the boom, look at the percussion, look at the pressures, and look at your environment. So you can look to the left, to the right, you can see your team members there. The technology team or the developers, they are bringing in things like a scenario, a fire breaking out. So we focused on your drill rig right in front of you. Meantime, you need to have situational awareness or environmental awareness to look around you and see if there's any other, other hazards being identified. So, which I think is encouraging for the future potential of this is the scenario creation that we can also do over and above just saying, listen, we are drilling holes. You can look at the rest of your mining team to the left and to the right. You can put people into the places. So part of the future potential for this is to say, create the whole room where people can do various types of jobs in a virtual environment. Again, making it safer for those individuals. Now we're quickly going to go over to the next video. I'm going to just play this for us. If you just give me a second, let me just go over to this. Okay.
So we're at the UJ Mock Mine today, and we're installing a virtual reality simulator of the Sandvik DD321. It's a double boom drill rig machine, and the whole simulation takes place inside of a virtual reality headset. And we're focusing on drilling practices, good practices, collaring correctly, your right angles, drill depths, crosscuts, inclines, declines, everything you can think about in drilling. We're focusing on teaching people the right way to drill and not just focusing on aligning your boom to the hole, pulling your levers and going ahead. We've focused on physics, displacement of weight, the rod bending, if you overfeed, overpercuss, all kinds of things, sliding on the wall if you overfeed. So yeah, and this is basically the unit. Well, for a mine, first of all, is you train your guys without training them on an actual expensive machine, putting people's lives at risk, putting lots of money at risk by maybe potentially damaging equipment. And then you can do it over and over, and you can have group participation, you can have your facilitator look at it, and you get your full report afterwards telling you what hole, how deep you drilled each hole, how accurate you drilled, if your drill alignment was correct on each specific hole. And then you're allowed to make mistakes. So where you're not allowed to make mistakes in the real world, here we actually kind of sometimes encourage mistakes to test what happens in that scenario, you know. If the machine catches fire, what does the user do? How quick does he respond? If there's a fall of ground, you check people's reactions and see how they respond to like scenarios that might put them under pressure. Yeah, that and practice. It's muscle memory. Everything is on the same spot. Everything's where it's supposed to be. So once you get onto the real machine, you'll actually have a good feel for what's going on here. You're also in a virtual headset, so you're a lot more immersed than say on a flat space. You're around, you can check around, you can check your blind spots, check different angles. So there's a whole bunch of terms that gets thrown around. There's like location-based VR or mixed reality or whatever, but it's basically, it's kind of like mixed reality where your physical world and your virtual world coexists in the same space. So when you put on the VR headset, you immerse into this computer world, like into the computer generated simulator world, but you still have your physical panels that are built up to scale to the Sandvik machine that you now use to operate the drill rig inside the VR. And then on top of that, we have the base stations that we're putting on now that works with the Vive. So it's infrared tracking, it tracks the position of the headset. so wherever the headset is, then you know. Then we also have the leap motion on the VR headset, and that also works with infrared on depth of your hands. So then you can see your hands in your virtual space, and then all of that links up. So the headset, the leap motion, the panel, everything then goes to the computer, and then the software and everything we do brings everything together and helps it to work together. Yeah. Well, for students, I think it also depends on what the student does. But if you're a rock engineer or studying as a mine engineer, it's a very good thing to go here and come and see how the drilling process looks, because you have a very good background of how the drilling works. You know, how the operator drills, and then you can see what mistakes operators might make that then cause problems at a later stage, where as you're an engineer, you don't really think about, oh, this operator might make a mistake like this that might cause me problems. But if you now see this firsthand and you can see, oh, okay, but sometimes there are really things that are difficult that I as an engineer must now take into consideration, because I saw that operators might struggle with certain things. So I think that's one thing. And also my personal opinion is everyone in a mine should at least know something about what another guy does. You know, I'm like a firm believer in, like, the operator needs to do some sort of fault finding, at least know a bit of the machine, the hydraulics and the circuitry, because it's just, and then operator and a miner, they also need to know each other's jobs, because they directly are reliant and dependent on each other. So I think it's the same for students, especially engineering students and mining students, to get a good perspective and some background information about what goes into drilling as a whole. Yeah.
There we go, ladies and gentlemen. So some exciting technology there. Maynard explaining to you some of the tech in terms of the drill rig, fault finding, things that can be done practically. It's not something that's out there and you just in a computer space. You're actually utilizing your hands on a real panel. It's a very practical way of doing training, again within a safe environment. So we're getting towards the end of our presentations. So the conclusion is that VR is not a replacement for the current training methodologies. Blended learning is recommended at the end of the day. It can be used for upskilling of miners, illustrating the consequences of non-compliance or incorrect marking, or, you know, where do I fit within the system, like we just saw within the previous video. Assessments can be done in real time. There's an example of one of the assessments of an actual marking of a student, where we can go and see what the pass value should be versus what the user value should be. You know, how many attempts has the individual had. It shows capacity prior to entering a work environment. Again, on-the-job coaching is done in a safe environment prior to going underground. VR requires specialized skills for the setup and support, but operating can be done by facilitators. So you will have a specialized setup, but facilitators can manage the day-to-day. There is the need for regulators to review training material and accept methodologies. Gamification contributes to learner uptake and engagement, which is excellent. I think it makes it, it merges the informal with formal. And there are exciting developments happening within the human development field. A shared vision to the incorporation of technology is required for successful uptake. I think us as a sector needs to understand what the potential could be of this technology being incorporated into our training and development. So I'm going to have a conclusion video, and then we will go over to the last few minutes for some Q&A. I think we might open it up afterwards due to the time constraints as well. I'll speak to Shireen and find out. But yes, here is the final video for us to conclude the session with.
Technology is evolving the mining industry at a near exponential rate. It's not only the tools we use that are changing, but the very nature of jobs that we use them in. Once a new technology rolls over you, if you're not part of the steamroller, you're part of the road. Never before has learning to operate tools effectively been so crucial. But in an ever-changing world, how do we determine the best ways to learn? True learning is about subtracting the convoluted and adding in the meaningful. Training methodologies have remained unchanged during recent history for both rock drill and drill rig operators. There are new training technologies available, but they are not being used to their full potential within our mining environments. The need for a skills realignment has been brought about by both the changes in technology as well as job requirements for mining modernization. The SAMURDI Successful Application of Technologies Centered Around People, or SATCAP research program, recognized a natural solution. The use of blended learning technologies in training could provide a strong platform and motivator for the use of virtual reality in the training landscape. The University of Pretoria set out to identify and demonstrate existing virtual reality training and blended learning solutions for rock drill and drill rig operators within the art of the possible in mining for modern training methods. There are some clear dangers that have always existed around drill operations. VR technology provides an immersive and real experience on what to do and expect during the drilling portion of mining. It also gives operators the opportunity to understand the drilling and blasting process. And most importantly, it provides learners the opportunity to experience the consequence of ineffective marking, drilling, and blasting. Virtual reality training cannot be used in isolation to other training methods. Classroom training, on-the-job coaching, and just-in-time training are still required. SATCAP Work Package 3 offers a virtual blended learning experience which encompasses the most effective methodologies specific to an individual field of learning. How did SATCAP Work Package 3's process work? Step 1. We gathered existing training methodologies and materials from OEMs and mines. Step 2. We identified ready-to-implement virtual reality training solutions for drilling and blasting in gold and platinum mines, aimed at improving safety, health, and productivity. Step 3. We piloted and tested virtual reality solutions in mock mine simulations for impact, value, and applicability. Step 4. The outcome of the pilot allowed us to make recommendations for the implementation and use of immersive technologies in training of rock drill operators, drill rig operators, and mining students. The University of Pretoria partnered with Sibanye-Stillwater, University of Johannesburg, and STS-3D on Work Package 3 to identify and demonstrate the art of the possible with regards to mechanized rock drill training, which included the installation of a first-of-its-kind virtual blast wall and mechanized drill simulator at the University of Johannesburg's mock mine. Given that there are numerous challenges in upskilling, reskilling, and cross-skilling our RDOs, we identified key areas where this technology could see the most immediate change. So, what has this resulted in? Through the art of the possible, we see positive impacts for thousands of our current and future rock drill operators in gold and platinum mines throughout South Africa. We've identified that a one-size-fits-all approach to technical learning doesn't work for mines. Mines need a blended learning approach based on their particular resources, people, and environment. Applying VR in a way that includes customized VR simulations, modern classroom educational technology, digital, and practical assessments has been seen to be the most effective. Mines have infrastructure differences. Wi-Fi and other needs for digital training therefore require each solution to be customized to said mine's infrastructural needs. VR simulations can be customized to any local OEM mechanized drill rig, for example, Artmaster, Epiroc, and Sandvik. Learners became increasingly more engaged and showed a more immediate uptake to the new learning approach. Blended learning is the next crucial step in developing meaningful and future-minded training. That is the art of the possible in mining.
So, ladies and gentlemen, that's the end of the session from my side. I will then just the last slide is for us to say that. So a little bit of time is unfortunately allocated to the questions and answers. Responses is from myself, Jan Bowden. I'm not sure if Stuart is still in the session, but I actually also want to thank you for attending our breakaway room and the session with me. So thank you for that. Are there any specific questions that I can answer?
Wessel,
Yes.
it's Bertha here in Paula.
Yes.
I would like to know, I came in a bit late here because of other commitments, but I picked up on a big portion of the videos and the presentation. What is the limit to this VR design? So we have looked at the blasting wall and to other examples here. Is it possible to design a entry examination, waiting place, the whole procedure in virtual reality?
Yes. Sorry, just your name again?
Moritz.
Moritz. Oh, Moritz. Okay, 100% Moritz. Perfect. Moritz, yes, it is possible. So part of what we actually looked at in the VR scope, and that wasn't illustrated as a video on its own, was to have specific pre-assessment, workplace entry assessments that need to take place. So there is, for instance, a tablet that you can interact with. Again, this is within a training center, so easy for us to utilize that technology there, where we actually have a tablet where there is let's say HIRA exercises that need to take place before entry. Now, if we look at this, the VR scope, there is, let's say, 12 steps that someone needs to take before they can even enter or get close to the rock face, which contributes quite a lot in terms of the hazard identification and the assessments that need to take place. So yes, there is a step-by-step VR process that we can do with that as well. That is developing further. At this stage, it's quite a big setup in a specific training room. I think the mobility of it is still one of those challenges, but the technology is getting there. If that answered your question, Moritz.
Wessel, if I may interject as well.
Please.
Hello, everybody. Yes, Moritz, basically the tablet that Wessel referred to is just your means of selecting the tool in the virtual setup. So in the virtual scope, you've got a scope that's 5 meters wide, 4 meters deep, and 1.5 meters high. During the entry examination, you have to bar exactly where you need to bar. You need to test for gas, you need to test for temperature, you need to test for ventilation. Should you miss a tight condition and you move underneath that tight condition, we simulate the fall of ground. So it's an actual role-playing game that you're playing to actually get through the entry examination before you can start walking off the face.
Thank you, Jan. That's perfect.
Yeah, thanks for that. Because if you look at the amount of fatalities that we had last year, if you just look at last year itself, it is again relating back to a lot of fall of ground in the industry. And for me, it is all of the VR, and I'm pro VR training, and I've been asking questions and I've been exposed to this before. But I think entry examination, that portion, however you look at it, whether it's blasting, how you want to fit it into, is that you still need to go through a portion of that training, and obviously the development needs to be done on how to do proper entry examination and your top procedure.
There we go. Sorry, as we get back, last few minutes I've left here. Marius, Moritz, are you back?
I'm back.
Okay, perfect. Sorry, you were busy saying that part of the you are a believer in the VR solution as well as a contributor to upskilling, but you were still saying that there was 1 or 2 considerations.
Yeah, it's just for me, what is, all of this is important. If you look at it and going into the VR environment, I would just I'm really interested in seeing a entry examination model designed on the VR system for conventional mines. That any mine can adopt to their standards or procedures.
Yes.
Now, I've been asking, and there's not anyone that could have shown or tell me that exists currently. And I understand it's because of ecumenism and the difficulty of designing such a setup because of space or because of the size of the magnitude of it. But it's just basically a comment I'm making. I'm always putting it out there for the companies that are developing this. Is that really, I think the need, and I've spoken to my team as well, is that if we can set up something like that somewhere on a mine or get a sponsor to assist, that we can tackle this problem and see if we can get around it.
Very much so, Maurits. And Johan, as far as I'm aware, you guys are working on such modules, and again, to increase the mobility, correct?
Yes, that is correct. We've got a couple of solutions for entry examination that plays off in a HMD in your headset. Obviously, for a headset, you can get away with little space as 4 square meters, preferably 9 to 12 square meters. But in that area, we can do an entry examination, to take you from the waiting place, from the bench, gathering your tools, testing for watering gun, everything up to the face, and including even after the blast if you want. So we've got a couple of solutions for a full entry examination for various mines, and obviously customizable completely to the client's needs. So yes, if you want to contact us, Marius, I'm sure we can talk to you regarding a solution.
Perfect, thank you, Johan. Maurits, I think good comments, and it is a consideration. I mean, if we look at the fatalities, spot on, it is still a big concern for us, and I think it will be an even bigger contributor to the health and safety at operations if we can get that successfully rolled out. So thank you for your comments. I genuinely appreciate it. Sorry, Henia, I'm going to put you on the spot a little bit here. I think a big thing is for us to also experience this. Now, we've got quite a few attendees here. At some stage, will UJ be willing to accommodate us, in little groups? If we can arrange something like that at some stage, so we can come and visit UJ there?
Vessel, anytime. We actually have a drone test tomorrow on campus that I have to go to. But if there's anyone like Maurits has spoken now that wants to come and have a look, if they give me a day or two advance warning, we can set something up. We can handle about 20 people at a time. Obviously, if there's more, we can just do it in batches. But yeah, we'd love to do it. I mean, that's exactly what this is about, isn't it?
Perfect, thank you, Annie. And that is exactly what this is about for the participants here, is that this is a collaboration that has happened across universities, across regulators, across providers, OEMs, and so forth. It's not a single solution that we are driving. We are looking towards the future, and a site like Henia and them at UJ have provided us is a practical area where you can go and view it. And Maurits, like your comments there, it's a practical area. Go and look at it. Go and look at making recommendations. We want to develop this further. OEMs like STS, Johan and them, they take that to heart. They take that input, and obviously they want to build what sector requires, and what the needs are. That's a big output for us. Any other comments currently that we still have? We still got another 4 minutes left, I see. Stuart, I see you in the session here still. The art of the possible. What have you found? You've been across the various work packages. Any comments there that you can see at where we are going in the future?
No, Vessel, not to add to the things that some of the specialists have done. I think what's already been mentioned is just the blended learning approach. But as Maurits was saying, this technology is useful across mines. And what's very exciting, I think, into next year is like where I'm just going to use Maurits as an example, and the fatalities around fall of ground and his comments around entry examination. this is where I think the future is. How do mines push and collaborate with the various partners, with each other, to say, how can we improve and use this technology in specific situations? And I think that's what's going to be exciting for me as a commentary into the future.
Perfect. Thank you, Stuart. And spot on again there. Ladies and gentlemen, our session is about to expire, but this is also a quick coffee break time for us. If you quickly want to run to go and get a cup of coffee, the next session starts at 11:33 into the main room. If we can maybe go and join there. And I want to thank you for joining our room here today. Thank you for your participation. I hope you see the potential of the technology. Again, this will be made available on the information management systems, but Marius and his team will speak about that a bit later in our main session. So thank you for joining. I appreciate your time and your consideration for being part of this room. Thank you very much.